In this lesson, I can find solutions of polynomial equations and zeros of polynomial functions. Okay, so let's just review solving by factoring. To solve an equation by factoring, you need to first make sure it's set equal to 0. Put the terms in descending order with the highest exponents on the left and the lowest on the right. Factor until you can't anymore, right? Use the methods listed in the flow chart. Always start with DCF factoring and then look at the number of terms you have left to figure out whether or not to use difference of squares, difference of cubes, sum of cubes. We could use grouping. We could use trinomial guess and check factoring. Okay, look at the number of terms. Once you have it factored, set each piece of the factored form equal to 0 and solve. Also, just keep in mind that when solving a polynomial, the answers can be called many different things. So sometimes I'll call the answers solutions or answers. Other times I'll refer to them as roots, zeros, or x-intercepts. All of these can be used interchangeably. Keep in mind as well that the biggest exponent tells you how many answers a problem will have. So if it's a quadratic equation, we're going to have 2 solutions, but some of them might be repeated. Some of them might be imaginary. So we're not always going to see that many solutions on our graph. Okay, and I put a note here that repeated solutions are going to be counted separately. Here's a little bit more about repeated solutions. This is a new term for us, multiplicity. I want you to go ahead and put a big box and star around this term because this is something new today. All right, it says there can be factors that are repeated. If this is the case, the repeated factor, 0, is called a multiple, and therefore you can state the multiplicity of that solution. Okay, so basically if one answer is coming up multiple times, it's going to have a multiplicity of something other than 1. You're going to just tell me how many times it's coming up. That's the multiplicity. It says the multiplicity is the number of times that the factor appears in the factored form of the polynomial. Okay, this is interesting. We'll need this for later. When a factor is raised to an odd power, or in other words, its multiplicity is odd, the graph is going to cross the x-axis. When a factor is raised to an even power, or in other words, if the multiplicity is even, then the graph is going to touch the x-axis. Sometimes I'll use the word bounce instead of touch. So let's take a look down here. You can see that this person used factoring by grouping in order to get that expression completely factored. And look down here, see how we have the factors x minus 1, x plus 1, and x minus 1? So how many times does the factor x minus 1 appear? X minus 1 appears once, twice. So we would say that its solution, x equals 1, would have a multiplicity of 2. How many times does the factor x plus 1 appear? How many times does the factor x plus 1 appear? Well, x plus 1 just appears once. Okay, the solution, -1, would have a multiplicity of 1 then. Okay. Remember, if the factor is x minus 1, then the solution is 1. Remember, if the factor is x plus 1, then the solution is -1. And we can see that here. Okay. So in my answer, I would say that x equals 1 has a multiplicity of 2. And I would say that x equals -1 has a multiplicity of 1. Okay, keep in mind that if the multiplicity is odd, then what's going to happen? Then the graph is going to cross there, versus if the multiplicity is even, then the graph is just going to touch or bounce at that x-intercept. So look at my x-intercepts. I have an x-intercept here at -1, and I have an x-intercept here at +1. At -1, what's happening? Is it crossing over the x-axis, or is it bouncing off the x-axis? It's crossing. And at +1, what's happening? Is it crossing, or is it bouncing and going boing? It's bouncing, right? It's just touching it and then making a turn. Okay, so this would be considered a bounce. And this makes sense because at -1, my multiplicity was odd, right? So it should have crossed. Whereas if my multiplicity is even, right, at +1, we had an even multiplicity. So that's why we saw a bounce happen at 1. All righty. In example 1, it says solve a polynomial equation by factoring. Okay, so that's what we've been leading up to, is solving by factoring. Remember, the first thing you want to always do is factor out the GCF. So here it looks like all of the terms are divisible by 2x. I'm going to divide a 2x out of every one of those. If I divide the first term by 2x, I get x squared. The second term by 2x, we would get minus 6x. And the last term, we would get plus 9. And you can see how much better that looks once I take a GCF out of it. I want to factor this completely, so I'll continue factoring x squared minus 6x plus 9. X times x is x squared. And then what are two numbers that would multiply to give you 9 but add to give you negative 6? Good, minus 3 and minus 3. Okay. So once it's completely factored, we set each factor equal to 0 and solve. So we'd have 2x equals 0, x minus 3 equals 0, and x minus 3 equals 0. If I divide both sides by 2 here, I get that x is 0. Here, if I add 3 on both sides, I get that x is 3. And really, I don't have to solve for that again. So we get x minus 3 again, so we get that x is 3. Any questions about that? If you want to complete your factorization and write this as 2x times x minus 3 squared equals 0, you can absolutely do that. It's still going to work the same, where you set each factor equal to 0 and solve. Here, if you divide both sides by 2, you get that x is 0. Here, if I square root both sides, we're still going to get that x is 3. You see that? Okay. So it works either way. Questions about that? All right, so now we're going to fill in some blanks. It says the solutions are blank and blank. What did I just get for my solutions? 0 and 3. Okay. Remember, synonyms for solutions are roots, zeros. Those are all synonyms. Okay. X-intercepts, right? That's another synonym. Here's what I want you to fill in. 0 has a multiplicity of blank, and 3 has a multiplicity of blank. Let's talk about what it means to have a multiplicity. The multiplicity is just how many times each factor appears. The multiplicity is how many times each factor appears. So how many times did the factor x appear? I guess it was not just x, it was 2x. How many times did that factor appear? Just once. And how many times did the factor x minus 3 appear? That would be twice. Okay, let me go look back. We start with our answer. Here our answer was x equals 0, and I look back at the factor that gave me that answer. How many times did 2x appear? See how 2x just appeared one time? What factor gave me the answer 3? The factor was x minus 3. How many times does the factor x minus 3 appear? Twice. Does everyone see that? So we would say that x equals 0 has a multiplicity of 1 because that factor only appeared once. X equals 3 would have a multiplicity of 2 because that factor appeared twice. Even if you would have written your answer in this factored form over here, you can see that 2x, that factor just appeared once. See how this was x to the first? And then x minus 3, you would still say that it appeared twice because of this squared. Does everyone see that? It's x minus 3 squared. So that exponent there would tell you that the multiplicity is 2. Because what that squared means is x minus 3 times x minus 3. Does that make sense? Okay. Alright, so that is the new stuff. Then down here we have some of the old stuff. What is the degree of my polynomial? What is the highest power of x? The highest power of x was 3. So this is a degree 3 polynomial. And what is my leading coefficient in front of x cubed? 2. That's my leading coefficient. So it's degree 3, which I should be noting is odd, right? And the leading coefficient was 2, which I should be noting is positive. And if I have an odd function with a odd degree function with a positive leading coefficient, we want to know something about the end behavior. Because the degree is odd and the leading coefficient is positive, the end behavior looks like what? Is it going to be the same or opposite? Opposite. And because it's positive, we're going to be starting pointing down and increasing as we go to left to right. Any questions about that? So you can see how we're putting all of these puzzle pieces together. Now I can sketch the graph without a calculator. I'm going to first plot my root solutions, or again, another term for it is x-intercept. I have an x-intercept at x equals 0, and I have an x-intercept at x equals 3. So at 0, 0, I have an x-intercept. And at 3, 0, I have an x-intercept. Okay? So that's always the first thing that I do, is I plot my zeros, or my x-intercepts. So again, I plotted it at x equals 0, and at x equals 3. Okay? The second thing I'm going to consider is my end behavior. My end behavior starts pointing down and ends pointing up. Okay, so that's the second thing you graph. The second thing you graph is your end behavior. So in this case, my end behavior was like this. And the third thing I graph is going to have to do with the multiplicity. This is my new topic today. If the multiplicity is even, you're going to see a bounce at that intercept. And if the multiplicity is odd, you're going to see your graph cross through that intercept. So I'm going to make a graphic organizer just to help summarize this. I'm going to list my zeros. I'm going to write what the multiplicity is. And then I'm going to describe whether or not there's a cross or a bounce. Okay, so what were my two zeros? I had an intercept at 0, and I had an intercept at 3. Okay? What was the multiplicity of 0? 1, because 2x disappeared once. And the multiplicity of 3 was 2, because my x minus 3 factor appeared twice. Okay? So then I'm going to describe what the behavior of the graph is at each 0. So I'm going to say behavior. Is my behavior of the graph at each 0 a cross, or is it going to be a bounce? Because 1 is odd, that's when you say that we're going to have a cross. Because 2 is an even number, I'm going to say that at even numbers, we bounce. Or it's just going to come up and touch the graph, and then it's going to rebound off of that intercept. Okay. So look at how I graph this. At 0, I said that I have a cross. So the options are I can either go through it, or I can bounce off of it. Those are my two options. I can either go through it and cross over it, or I can come up and go boing and bounce off of it. At that 0, it says that I'm going to have a cross. So I'm going to cross through it. Okay. Then I'm going to return to my other intercept. My other intercept's at 3. And what am I going to do at 3? Am I going to cross through it? Or am I going to boing, bounce off of it? I'm going to bounce off of it because that multiplicity was even. Okay. And it makes sense that I would bounce off of it because then look what happens. I'm going to go up here and I'm going to meet my end behavior. Okay, so that's how you know you did the correct crosses and bounces. You're good. Yeah, thank you. It's because it should match up with your end behavior at the end. So you always start at the left and work your way left to right on your graph. Any questions about that? So let's try just one more, and then we'll call it for the day. This is just a summary of what I just said. When a factor is raised to an odd power, then the graph crosses. When the factor is raised to an even power or has an even multiplicity, then the graph touches or bounces off of that intercept. Okay, that's where you see your boing. It does not cross. All right, so again, I'm going to find the zeros, then I'm going to sketch a graph of the function. That's what I just did in the last example. So here I need to start by factoring this expression. Do we see a GCF? Negative 2. So I'm going to have x to the 4th minus 8x squared plus 16. Okay. Then I want to try to factor this trinomial. X to the 4th minus 8x squared plus 16. What times what is going to give me x to the 4th? X squared times x squared gives me x to the 4th. Can you think of any numbers that multiply to give me 16, but add to give me negative 8? Negative 4 and negative 4. Right, let's just make sure that works. My outers here would be negative 4x squared, and my inners would be negative 4x squared. Doesn't that give me a negative 8x squared? It does, that works. Can I factor this guy anymore? Yeah, it's dots, right? X squared minus 4. Each of these can be factored using difference of 2 squared. Same thing with this one. Okay, so I'm going to do that for each factor. Okay. So x squared minus 4, I'm going to write that as x plus 2, x minus 2. And that takes care of my first x squared minus 4. Then I have to do the same thing over here. X plus 2. X minus 2, and that takes care of my second x squared minus 4. If you want to clean this up a little bit, how many x plus 2 factors do we have? 2, so you could write this as x plus 2 squared. And how many x minus 2 factors do I have? 2. Okay, so I can write that as x minus 2 squared. Okay, so I'm going to set each factor equal to 0 and solve. 0 equals negative 2, 0 equals x plus 2, and 0 equals x minus 2. I pretended like I already square rooted both sides because the square root of 0 is just 0. Okay, can I solve for a variable in this left equation? 0 equals negative 2. Yeah, there's no variable to solve for. So I don't have to worry about that one. Here, if I subtract 2 on both sides, I get that x is negative 2. And here, if I add 2 on both sides, I get that x is positive 2. Okay, so let's think about multiplicities. What is a multiplicity for x equals negative 2? Look back at the factor. I want to know how many times did the factor x plus 2 appear? The exponent says twice. See how I had x plus 2 here? That's once. And x plus 2 here? That's twice. Okay, so this is a multiplicity of 2. What about positive 2? What was the factor? X minus 2? How many times did the factor x minus 2 appear? Twice. Right? X minus 2 appeared once here and 1's here. So this is the multiplicity of 2 as well. Okay, so I'm going to use that information to help me graph this expression. Okay, so let's fill out the blanks. It says list the zeros and multiplicity of each. So we have negative, which one did I use for what color? Negative 2 was blue. We had negative 2 had a multiplicity of 2. Okay. And then we had the positive 2 had a multiplicity of 2. What was the degree of my polynomial? It is a degree 4 polynomial with a leading coefficient of negative 2. Degree 4, leading coefficient of negative 2. Because the degree is even and the leading coefficient is negative, the end behavior looks like what? Even is that same behavior or opposite? Even is same. Odd is opposite. Okay, so same, and then the leading coefficient is negative. So would they both be up or both be down? They would both be down because that leading coefficient is negative. Okay? So we're going to sketch the graph. What's the first thing I always sketch whenever I'm drawing my picture? What's the first thing we plotted in the last graph? X-intercepts, or the zeros. Okay, so what were my solutions? Negative 2 and positive 2 were my solutions. Okay. Negative 2 and positive 2. Okay. There are my intercepts. Then the second thing I graphed was what? My end behavior, which we know here has end behavior would both be pointing down. And the third thing I need to do is know what my behavior is at each x-intercept. So I'm going to use the multiplicity to help me with that. And I like to just make a quick little graphic organizer and list in my graphic organizer the zeros, the multiplicity of each, and what the behavior is. Is the behavior going to be a cross or a bounce? So at negative 2 and 2, those were both my x-intercepts. What was the multiplicity of each of those? 2. So would we see crosses or bounces? It would be bounces. Both of these are even. So we're going to see a bounce at each intercept. Okay, so that's how I determine what's happening at each intercept. So going over here, I have two options. I can either cross through it, or I can go boing and bounce off of it. Which one is going to happen? Okay, so I'm going to come up to this first intercept, and I'm going to bounce, and then I'm going to come up to the second intercept, and I'm going to bounce. And you can see how I'm meeting up with my proper end behavior. See how both sides are supposed to be pointing down? Okay. This is a rough sketch. So I'm not really worried about this section. I don't really care how far down you come. Okay. What I care about are these three components. Do you have your x-intercepts plotted? Do you have your correct end behavior? And do you have the correct crosses or bounces? That's what I'll be looking for. Any questions about that?